Okay, I'm going over the Unit 7 review. On number 1, it's asking us to take a triangle ABC, map onto A prime, B prime, C prime with this transformation. And for part A, it's asking you if the length from A to B is 9, what would A prime to B prime be? The first transformation is just a translation. It moves it left, right, up, and down. It does not change the length. So with this first transformation, without this, it'd still be 9. Now this one is a dilation, and basically a dilation will change this so there'll be 3 times this length. So A prime, B prime will be equal to 9 times the 3, which is a length of 27. Number 2, if our coordinate 3, 1 is B, what's the coordinate of B prime? So it's going to go through this transformation. Keep in mind that 3, 1 for B is the original point. So what we're going to have to do is we're going to have to transform this first with the translation. So we'll do 3 minus 2 because x is 3. The y is 1, so it'll be 1 plus 1. And this will get us a total of 1, 2. And from this 1, 2, we are going to have to do this dilation of multiplying by 3. So we're going to do 3 times 1 and then 3 times 2. 3 times the x, 3 times the y. And this will get us our final answer of 3, 6. Okay, this next one is going to be looking at taking this image here and doing a reflection for part A. I'm actually going to go ahead and do that right on here. So let me zoom in a little bit for you. Let's see if I can get this zoomed in a little bit. All right. So taking a look at this first one right here, we're going to reflect across the x equals 3. So x equals 3 right here. I'm going to go ahead and draw a dashed line, and we're going to reflect. Now in this reflection, it's going to go past this line onto the other side. So this first point is going to be 1, 2, 3, 4 away. So it's going to be 1, 2, 3, 4 away from the other side. And that point right there is, I guess I need my glasses, that is D. So this is D prime. Then I'm going to go ahead and take this, and it's right on the line. So actually this is not going to move at all. That will be your F prime. And E is again 1, 2, 3, 4 away. So we'll go 1, 2, 3, 4, and that'll be E prime. And this will be considered a reflection across this x equals 3. This next one right here is a rotation of 90 degrees clockwise. Clockwise goes in this direction. So since I don't have my tracing paper with me, I'm just going to go ahead and do this and list out what the coordinates are. So if you take a look at this original picture and rotate it 90 degrees clockwise, the final graph should look like this. So I'm going to write these coordinates sideways just so I could see. So my L prime is going to be, and we're going to pretend that this is my x and this is my y. So this is at 1, 2, 3, 1. So that'll be at 3, 1. All right, and then we're going to go ahead and take my n. So this is n prime. N prime, we're pretending this is x and y. So this is going to be at 4, negative 4. So 4 and negative 4. And then this last one is m prime. And this will be at positive 1, positive 2. 1, 2. All right, now I'm going to go ahead and move this back to its original state, which is this way. I'm going to go ahead and plot these points. So my L prime is at 3, 1. My N prime will be at 4, negative 4. And my M prime is going to be at 1, 2. Oops. All right, let's go ahead and take a look at this next one. So in this next one right here, we have a triangle, And this is the one we're going to label the side lengths here in this picture. So my side lengths that I have are QT, which is Q up here, and T is right here, that's 8. And then from T to S is 4, and where it's asking what is the length from R to T, so I'm going to go ahead and make that X. And then we're going to find the area afterwards. So let's go ahead and first set this one up. So let me go ahead and take my sketch paper back here. And so remember that for setting this up, this side is the medium triangle, this is the small triangle. This is the medium side length of the triangle. So medium 8 over X, this is the medium of the small triangle, equals, and then we're going to go X right here of the small sides of this triangle over the small side of this triangle, which is 4. So 8 over X equals X over 4. And then we're going to cross multiply. X times X is X squared. 8 times 4 is 32. We're going to take the square root of both sides. Since it's a side length, it's not plus or minus. We'll break down the 32. That's going to be 8 and 2, which bring, 8 and 4. And this 8 breaks down to 2 and 4. And I have a pair of 4s, so that goes outside and the 2's inside. So 4 root 2. So that's the length of RT. All right, and then to find the area of this triangle. So the area of a triangle is basically finding 1/2 base times height. Now, most of the time you want to think base is here and height is here. But since I already have an altitude this way with the 90 degrees, this is my height. And this is my full base. And the full base is 8 plus the 4, which makes 12. So the area is 1/2 the base, which 8 plus 4 is 12, times the height, which is X. And we found X to be 4 root 2. All right, let's go ahead and simplify. Half of 12 is 6. 6 times 4 is 24. 24 root 2. And don't forget your units. Our units are in meters. And so it's meters squared for the area. And the length of RT, I should put the units here, that's also meters. Let's take a look at the next one. Okay, on this next one right here, we know that the length from J to I is a length of 10. And we want to find the length from J to K. So this is the side we're solving for. Now, notice that I have 2 little marks here. That's an isosceles right triangle, which means that this is a 45, 45, 90 triangle. And if you remember setting up the side lengths would be across from the hypotenuse is n root 2. And these are n. So for number 4, I'm going to make n root 2 equal 10, so I can solve for what n would be, which means I have to divide both sides by root 2. And then you can't leave your answer with a radical in the denominator. So in order to do that, we're going to have to rationalize, multiply top and bottom by root 2. And that gets you 10 root 2 over 2. But you can reduce the 10 over 2. 2 goes into 10 5 times. So the side length is 5 root 2. And this is not any particular units here. So it's just 5 square root of 2 units. Oh, sorry, that's not the perimeter. That's actually just the side length of n. Now to find the perimeter, we're going to take that length, which is the 5 root 2, which is both of the sides here, 5 root 2 plus the other side, 5 root 2 plus the bottom, which is 10. These two are like terms, so that's 10 root 2 plus 10, and the units were not given, so this is actually our perimeter. All right, let's take a look at the next one. Okay, on this one right here, it's asking us to state all the angles that are congruent. These are set up in a particular order. LMN is similar to PQR. So you line up the angles. Angle L, which is the first letter, is congruent to angle P, the first letter in the other triangle. Angle M is congruent to angle Q, that's the middle letter. And angle N is congruent to angle R, which is the last letter. Knowing sides that are proportional, we can basically take any two letters as long as it coincides with the letters in the other side. So if I use LM, that goes along with PQ. That should equal MN, which is the last two letters, over QR, as well as LN, first and last letter, with PR. And that would be proportional sides. Alright, this next one we have Ryan that is 6 feet tall, and a certain time of day he casts a shadow that is 12 feet long. At the same time, a tree casts a shadow that is 28 feet long. What's the height of the tree? So here's Orion. He is actually 6 feet tall. He casts a shadow. Shadows are on the ground, and this is 12 feet. And then we have a tree that's next to him somehow here. And this tree casts a shadow, which is also along the ground, that is 28 feet long. We want to know the height of this, so I'll make that H. All right, well, we're going to use proportions here. So let's go ahead and look at the proportion of the left compared to the right. So 6 is the height of the person, so the height of the tree, we don't know, equals, and then 12 over 28 this way. All right, you could also have done 6 over 12 equals H over 28. That would work too. All right, I'm going to cross multiply. So I have H times 12, so that's 12H equals 6 times 28, and 6 times 28, and 6 times 28 is 169. Divide both sides by 12, and H is going to equal 14 feet. So that's the height of the tree. All right, to find the geometric mean, it's basically going to be x divided by this 3/5, which equals the 10 over 7 divided by x. And when you cross multiply, x times x is x squared. That's going to equal 3/5 times 10 over 7. I'm going to go ahead and reduce this here. You can multiply across the top and bottom and reduce, but I'm going to go ahead and cross reduce. 5 goes into 10 2 times. And there's nothing else to simplify there. So we have x squared equals 3 times 2 on top, 6 over 1 times 7, 7. Get rid of the square by taking the square root. Keeping in mind you cannot have a square root in the denominator. So we're going to have to multiply this by the square root of 7 on top and bottom. So our x is going to equal, this is inside the radical, this is inside the radical, so we'll put it together. 6 times 7 is 42 over square root of 7 times square root of 7 is just 7. Okay, so number 8, we're looking at the part A, which is finding the length of LT. Since LT right here is the missing side length of a right triangle, we can use the Pythagorean theorem. So I'm going to use a squared plus 6 squared equals 10 squared. Or if you want to use your Pythagorean triple, you can. I'll go over that in a minute. So a squared plus 36 equals 100. Subtract the 36 to the other side, gets us 64. Take the square root, and that gets you 8. Now, if you didn't want to have to do all this work right here, you could have noticed that, oh, this looks like a 3, 4, 5 triangle. So 3 times 2 is 6. 4 times 2 gets you the 8, and 5 times 2 is the 10. So you could have used the Pythagorean triple. Either way, 8 is going to equal, oh, and it's, by the way, in centimeters. 8 centimeters is equal to LT. All right, let's look at part B. Now that we know that this side is 8, we can go ahead and find all these trig ratios. So to find sine angle F, keep in mind that angle F is our reference angle, so this is up here, that's our theta. All the way across is opposite. The hypotenuse is over here, and the adjacent side's over here. So sine is SOH, S-O-H, or some old hippie. And so it's opposite over hypotenuse. And the opposite side is 8 over the hypotenuse, which is 10, but that reduces by 2, so you have 4/5. Leave it as a fraction. All right, and then C is finding cosine. of angle F. So cosine is k a over h, adjacent over hypotenuse. Adjacent is 6 over hypotenuse, which is 10. Reduce it by 2, you get 3/5. And then it says, what is the measurement of angle F? So you could use either one of these two to solve for that. I'm going to go ahead and use this last one for part D. So we knew that cosine of angle F was equal to 3/5. But if you remember how to get the cosine to go away is doing the inverse. Cosine inverse to solve for an angle measure. That goes away. So we have F equals cosine inverse of 3/5. And you need to be in degree mode when you do this in the calculator. So make sure that it says degrees when you have your calculator, which is right here. And then we're going to do second and then the cosine button. I don't know if you can see this, but it's a little bit glary. Okay, so let me try putting it over here on this side. Maybe you can see it better. We'll see if it pops up. Second cosine, no, I can hardly see it, but 3 divided by 5 is what we're putting in inside of the parentheses, and that gets us angle F as being about 53.13 degrees. Okay, and I don't think you'll be able to see this. There's too much of a glare. Okay, let's go ahead and take a look at this next one. Okay, this next one right here, I'm going to put the side lengths that are given. AC we know is 4. We know AD is 9. And we have to find the length of AB, so I'll let that be X. All right, notice that they did give us a similarity statement here, so we know it goes together. So I'm going to let this be my top numbers. This will be my bottom numbers for my ratios. So AC comes from the first triangle, and so that's going to be 4 on top, over, now AC is the first and last letter. So it should go with AB in the other triangle. And AB we know is X, equals. AD we know is 9, and AD is from this second triangle. So the second triangle, that should be on the bottom, 9. And AD is the first two letters, which goes with AB in the first triangle. And AB we know is X. All right, let's cross multiply. X times X is X squared. 4 times 9 is 36. And the square root of 36 is just 6. And that's the length of AB. Okay, so this next one right here, we're solving for angles and side lengths. So you're going to have to find a lot of information from this picture here. Let's go ahead and find the first one. We're finding the measurement of angle NQP. So here's N, here's Q, and here's P. You want to find this small angle right here. Now it's kind of hard to see. I don't really see any angles in this triangle. That's not going to help me out. But I do notice that we have this information that LM on top is parallel to PQ. So if these are parallel to each other, and I extend this up here, do you see your little backward Z? These are alternate interior angles. Since that's 53 degrees, this must be 53 degrees here. Okay. Likewise, if you wanted to find angle QPN, which Q is down here, and then P is over here, and N is up here. So we want to find this corner angle right here. And this corner angle, you can't use the triangle, but remember how we went all the way up? We have the Z again. Parallel lines on top and bottom. Alternate interior angles. So if this is 45, this must be 45 degrees as well. All right, and then the next angle measure that they want us to find is P and Q. So here's P, here's N, back down to Q. Oh, now I do have a triangle. We're looking at this little triangle on the bottom here. If I want to find this angle up here, I have two angles. I could take those two, add them together, and subtract it from 180 degrees. Okay, so let's go ahead and do that math. So we have 180 degrees minus 45 plus 53 is 98. And if you subtract, you get a total of 82. So it's 82 degrees here. Okay, what we're going to do is we're going to go ahead and find the side length here, QN. So here's Q, here's N. That's this big line that I already drew in here. You're going to have to look for a side length. So we do have the fact that we have this small triangle here, right triangle here, and this triangle here. They're kind of across from each other. Those are actually similar triangles. Why? By angle. This is 90 degrees, this is 90 degrees, and then these are vertical angles. So by angle, these two triangles are similar. So I'm going to use that to help me set it up. So first of all, I'm going to go ahead and take the value that is either one, it doesn't matter. So I use 12. So 12 goes with 18 on the bottom, which equals, and then again from the top, 20 over, and we don't know what this is. So we can write NQ or we can write X. All right, let's cross multiply. 12 times NQ equals 18 times 20, 360. Divide both sides by 12. So NQ is going to equal 30. So that's 30. All right, so that's the 30 for NQ or QN. All right, now PQ. PQ is the length from here all the way to the end there. So I already know this side is 18. So if I can find what this length is right here, I can just add them together. So let's go ahead and find out what is that value. So let's go ahead and start with the fact that we know that this is a 45, 90 triangle right here. It's an isosceles triangle. So if this side is 24 root 2, and remember that your side length is in root 2, then I can find these two sides. So since n root 2 equals 24 root 2, we can go ahead and divide by root 2, and we know n is 24. So this is 24 here for the length, and this is also 24 down here, which means the full length is just 24 plus 18, and 24 plus 18 gets you a total of 42. All right, and then the last thing that we want to solve for is the length from N to M. So we have N is here, and M is right here. So this is the length that I want to know. Now, I happen to know that this is a 45, 45 again. 90 is right here, 45 there, 45 here. So I want to find the hypotenuse. Now, if I know this side, I can just multiply that by root 2. Well, I happen to know this whole thing is 28. So let's subtract 12 from 28 to find this length. So 12 minus 28 gets you a total of 16. So this would be 16n, and then 16 root 2. So n root 2. And that would be the length of n. Okay, this next one is find the length of the leg of the right triangle. Leave the answer and simplify it out of the board. I happen to know two sides of the triangle. All I need is one missing side. So actually that's just the Pythagorean theorem. So we're going to do a squared, which I'm leaving it as a, plus b squared, 21 squared, equals hypotenuse, 27 squared. All right, we're going to have to do a little bit of work here. So 21 squared is 441, and then 27 squared is 749. Subtracting the 441 gets us a squared equals 288. And I'm going to go ahead and simplify by taking the square root and breaking this down. So I noticed that I have 288, so I know 2 goes in there. 144 times. 144 is 12 times 12. So I have a pair of 12s that will go outside and a 2 left over inside. So A equals 12 root 2. Okay, this next one says it has a right triangle, so we can use the Pythagorean theorem again here, where we know the 3 sides. Now, how would you know which is the C side? It's got to be the longest side. If this is X, that's got to be the smallest because you're adding 21 to get the middle and adding 24 for the largest. So you have x squared plus x plus 21 squared equals x plus 24 squared. And we're going to solve for x, and after that we can go ahead and find the side lengths by plugging it back in for the other values. So that means we're going to have to do a little bit of work here. So we're going to multiply this out. So x plus 21 squared is x squared plus 21 doubled, 42x, and then plus the 21 squared, which was 441, equals, here we're going to multiply this out, and so you have x times x, which is x squared, then you have 24x, but doubled, so that's 48x, and then 24 times 24 is 576. Just a little quick reminder, just in case you're like, how did you get that? Remember what it means to square something. So I'll do that a little bit of work on the side here. X plus 21 squared means the same thing as x plus 21 times x plus 21. And that's when you do the x times x. X times 21. 21 times x. And 21 times 21. And if you notice that this is the same thing twice, which is why I doubled when I wrote it here. Okay, just a little side. All right, let's go back to this, and let's add our like terms over here. X squared plus x squared is 2x squared. We have the 42x, the 441. All right, I'm going to go ahead and move everything to one side of the equal sign. So I'm going to subtract this x squared. I'm going to subtract the 48x. And I'm going to subtract the 576. So everything cancels on that side. All right, 2x squared minus x squared is x squared. 42 minus 48 is negative 6x. And then subtracting this gets you a total of 135. All right, anytime you see an x squared and everything's equal to 0, I'm probably going to have to do a t-chart to solve. So x times x, two things that multiply to get 135, 15, and 9. And I want the this to be a negative 6 out of this. So I'm going to make a negative 15 and make the 9 a positive. So we have x minus 15 times x plus 9. And we want to set each one equal to 0. So we get x equals 15 and x equals negative 9. Well, you can't have a negative side length, so 15's got to be the side length that I'm going to use. All right, now keep in mind that we have to find the length of all three sides, which is x, x plus 21, and x plus 24. So the first value is 15 units, and then the next one is 15 plus 21, which gets us 36 units. Oops, let me move it over. 36 units. And then we have 15 plus 24, which gets us a total of 39 units. So we have 15 units, 36 units, and 39 units. Those are the three side lengths. Okay, this next one is asking us to solve for WXY, and I noticed this is going to be special triangles because of the fact that this says 30 right here. This is a 30, 60, 90 triangle. And since I have these two sides equal and it's a right triangle, this is a special 45, 45. So we're going to use all those special values. Now, before I start, I'm going to have to take a look at the information that's given. So I know the hypotenuse right here is 36. So if you remember the side lengths, this one right here for the 30, 60, 90, across from 30 is n. And then the hypotenuse is 2n, and then the side next to it is n root 3. Okay, so let's go ahead and use that information. I know this is 36. So 2n equals 36 dividing by 2. We know n is 18. So I know this is 18 right here. Let me go ahead and put that in. So 18 is the length of this little height here. And if you look at 45, 45, that'd be 18, so 18, 18, n, and then n root 2, 18 root 2. This is for your 45, 45. And then on the other side right here, 30, 60, 90, I know n is 18, so to find y, n is 18, so it's 18 root 3. So basically we just solve for all the values. So we have w, which is over here, 18 root 2. We have x, which is right here, 18. And we have y, which is right here, and that's 18 root 3. And, oh, I think I missed finding the last part. No, I guess that's it. Okay. Just so you know, the answers on the back page are off. It doesn't have W, X, and Y like it has in the picture. It has X, Y, and Z. So just make sure you know that this is the correct answer with. Okay, on number 14, we're going to solve this right triangle, which means I have to solve all parts of it. So let's go ahead and solve, let's solve for angle A. So if angle A is my reference angle, then I'm going to use my trig function to find the measurement of this angle. So my two sides that I'm given, this side would be considered adjacent. This is the hypotenuse. And which trig function uses adjacent and hypotenuse? That would be cosine. So cosine of angle A, which is what we're trying to find, and that's our reference angle, equals adjacent over hypotenuse. So that's going to be 29 over 32. To get rid of cosine, you have to do the cosine inverse. Remember, we do the inverse to solve for angle measures. So angle A is going to be the inverse cosine of 29 over 32. So we're going to have to plug that into our calculator. So don't forget to hit the second button before you put in the cosine so you can get that little -1 to show up. And then you get a total of approximately 25, let's see, does it say what to round off to? Round all angles to 1 decimal place. So 25.0 degrees. So we know angle A. Since I have angle A, I know angle B. Since this is 25 degrees, I know a triangle all adds up to 180 degrees. So I'm going to go ahead and find angle B by taking 180 and subtracting the 90 and the 25 together. So that's 115. And then subtracting that gets you a total of 65 degrees. So that's the measurement of angle B. All right, and now let's go ahead and move on to angle C from here, because you have to do all the angles. Well, C is already given to us, it's 90 degrees. All right, so we found all of the angle measures. I'll go ahead and put that in. We said 25, angle B was 65, angle C is 90. All right, now we're ready to find the side lengths. Now the side lengths are the values that are across from it. Actually, I already know B and I already know C. They're across from the capital letter. So angle A is going to be across from side A. That's the only side I don't know. But I know B. B across from that's 29 already. And C across from that is 32. So all I really need is side A. And if I know two sides of right triangle, I can find the third side by just using the Pythagorean theorem. So let's use the Pythagorean theorem here. So we have A squared plus B squared, so 29 squared, equals 32 squared. All right, let's go ahead and figure this out. So 29 squared is 841, and 32 squared is 1024. Let's subtract the 841 to the other side. So we get A squared equals 183. And in this case, they're asking for us to actually find the values in decimal form. I think on the back though it has it as just a radical. So A is equal to the square root of 183, which is not, we can't break that down. Let's see, 8, 9, 10, 11, 12. 3 goes in there. 3 goes in there, total of, let's see, 3 goes in there, a total of 61, and 61 doesn't break down anymore. So it's just going to be square root of 183. for side A. And because it says simplest radical form for the side lengths. All right, let's go ahead and do special triangles here. And you have to know the ratios that go along with the side lengths of your 45. So we're using our knowledge of our special triangles. So I'm going to go ahead and put my triangle values here just so we can review it. 45, 45, and the side lengths are n, root 2. And then for our 30, 60, 90. So across from 30 is your n, across from the hypotenuse is 2n, and the cross from 60 is n root 3. All right, let's go ahead and solve for our trig values. So for part A, we want to find cosine of 45 degrees. Now keep in mind we have two 45s. It doesn't matter which one you use. I'll just use this one. Cosine is adjacent over hypotenuse. So if you take a look at the adjacent side of 45, that's n, over the hypotenuse, which is n root 2. N's cancel, so you have 1 over root 2. But you can't have a square root in the denominator. We're going to have to rationalize that. So I'm going to multiply top and bottom by root 2. All right, and then that simplifies to 1 times square root of 2, which is square root of 2, over square root of 2 times square root of 2 is just 2. All right, the next one, part B, is solving for cosine of 60 degrees. Again, a cosine is adjacent over hypotenuse. That's what we're going to look for. All right, let's take a look at 60 degrees as being our reference angle. But this is 60. Adjacent is n over hypotenuse, which is 2n. N's cancel, so you just get 1/2. All right, the next one, part C, is, let me scoop this up a little bit. Oops, it's stuck. All right, so C is solving for sine of 60 degrees. So sine of 60 degrees is going to be opposite over hypotenuse. 60 degrees is our reference angle, so we're going to use this angle. And opposite of that is n root 3 over hypotenuse, which is 2n. Now the n's cancel, so it's just square root of 3 over 2. And then the last one of these is sine of 45 degrees. All right, so we're going to use our right triangle again. We'll be looking at sine being opposite over hypotenuse. And we have our 45, it doesn't matter which one you use. But opposite would be n over hypotenuse, which is n root 2. N over n root 2. N's cancel. The root 2 is in the denominator, so keep it on the bottom by moving or putting a 1 divided by. Can't leave your answer like this. You have to rationalize. So 1 times square root of 2, square root of 2. Square root of 2 times square root of 2 is just 2. Okay, this next one, I'm going to go ahead and use the picture here. It says antenna on top of the roof of a 100 foot tall building. So I know this is really small to see, but this is 100 right here. And then we have from a point 50 feet from the base of the, 10 feet from the edge. So this is the 10 feet from the edge. So this is kind of inwards right here, 10 feet. And then, so I'll put the 10 right there. That's 10. And then we want to know, let's see, point 50 feet from the base of the building. So this is your 50 right here, feet. Put little quotes for feet here. And then we have the angle from the ground level to the top of the antenna is 66. So ground to the top of the antenna, 66 degrees. Find the value of x, which is the length of the antenna to the nearest foot. So this is x that we have to find. All right, I'm going to go ahead and draw in this little right triangle that we're looking at. So this is here. It goes across. And now keep in mind, this is going to go straight down like this. Okay? So we just want to find this x right here. Now keep in mind, this right here is 100. Even though it's over here, that's the same length for here. And this is not just 50 because we're going from 50 all the way to here. So this is 60. feet. All right, so we're going to use some trig here because we have the angle measure. So what I'm going to do is I'm going to pretend I want to find this whole height of this whole thing, and then at the end I'll subtract 100 to find this little missing piece. So I have adjacent and I have opposite. Opposite and adjacent is tangent. So I'm going to use tangent of the angle measure, which is 66 degrees, equals opposite. So I'm going to go ahead and let that be h for the height of the whole thing, divided by the adjacent side, which is 60. Remember 60, not 50. 60 because it's the 50 plus the extra 10. All right, from here I'm going to go ahead and cross multiply to solve. Put this over 1. 1 times h is h equals 60 times tangent of 66 degrees. All right, I'm going to put that in the calculator. Don't forget you need to be in degree mode. So 60 tangent of 66 degrees ends up being 134 point, does it say what to round off to? Nearest foot. So 135. So h is 135, but that's not the answer because we just want the antenna part. This whole thing from here to here is 135 feet. So if this is 100, then this has to be 35, the rest of it. 100 subtracted from 135. Okay, for this next one right here, I'm going to go ahead and plot this, these points. They look like they're all positive. And from here, I'm not going to put in all the hash marks. We're just going to take a look at the side length. And technically, if we want to find the scale factor of a dilation, we don't need to know all 4 sides and plot them all. We should need to know the length of one side to the length of the other side, knowing that it's in the correct order. So I'm going to go ahead and put this. So this point right here for A is 1, 2, and I just need one other point for this. Let's use B. So B is 1, 5. So there's B. So I'm just going to compare the length. Now they both went over 1, but one started from 2 and went up to 5. So 5 minus 2 is 3. This is a length of 3. All right, let's go ahead and do the other coordinates. So the other coordinates with A prime is 3, 6. So say 3, 6 is right here. That's your A prime, 3, 6. And our B prime is 3, 15. So 15 is way up here. A prime, 3, and 15. So I'm going to go ahead and draw this line right here for A prime, B prime. And so if you take a look at it, still 3 for the x's, but the length from 6 to 15, you go 15 minus 6, which is the length of 9. All right, so when you talk about a scale factor is taking the image over the original. And if you take a look at their image, that's this right here, which is 9, over the original, which is 3. So the scale factor is 3. From the original, it got longer by a length of 3. Okay, so what we're going to do is we're going to go ahead and take a look at a coordinate from A to B. Keep in mind that if this says 3 to 6 parts, that's going to be a total of 9 parts. And so we're looking at the ratio of 3 over 9, which is the same thing as 1/3. So it's going to be a third of its length. All right, so let's go ahead and start off with the distance. Now, if it helps, you can draw a visual. So -2, 3 is over here for A. Now put that in, -2, 3. And then you have 16 and then 12. So over here is B. So 16, 12. All right, so we're going to find the distance. So we're going to have to do this for x, and we're going to have to do this for y. So if you take the distance from the x values, looking at the -2 and 16, so the distance from here to here is a distance of 18, 16 plus the extra 2, 16 here, 2. So that's 18. And we're going to take 18 and multiply this by 1/3. We want 1/3 of 18. So this is going to be 6. All right, let's do the same thing for the y's. So the y, so the distance going from 3 to 12. So 3 is here, we're going up 12. So that will be a distance of 9. So we want to do 1/3 of 9, which is 3. Now keep in mind that we are going to take our original coordinate, which is -2, 3, and we're going to change this so that we will take the x and add 6 to it. Oh, and sorry, that should not be an end of a parenthesis there. So just x plus 6, and then the y should be plus 3. All right, so let's go ahead and take this and add it. So -2 plus 6, and we have 3 plus 3. So that gets you a total of 4, 6. So 4, 6 is the coordinate of the new point P. Okay, so for number 19, it says that the height of a given equilateral triangle. So I'll go ahead and draw an equilateral triangle. These are all 60, 60. Sorry guys, a little glitch there. All right, so we had the equilateral triangle, so 60, 60, and 60. We have a height of 5√3, so this is 5√3 for the height. Keeping in mind that this is a special little right triangle here, knowing that it's 30. So if I know this height is 5√3, which that would be n√3, we can say that the n is going to be 5. So we know that this length is 5 here, which means that this length is also 5, for a total of 10 across the bottom. So to find the area of a triangle, that's 1/2 base times height, and the base is 10, and the height is the 5√3. And then half of 10 is 5, and 5 times 5, that's 25√3, and this is in meters, so meters squared for area. All right, let's go ahead and draw a picture for this next one. It says, what's the measurement of angle F if you have a given right triangle? So I'm going to draw a right triangle here. And it says that the right angle is at E. So it doesn't matter where you put the other letters. So I could put F and G here. It doesn't matter which order. All right, now I also know that EF is 12, and I know EG is 5. I'm solving for what is this angle measure of F. So I could put theta right there. So I'm going to use trig when you're finding an angle. So you want to look at opposite here and adjacent, which is tangent. So tangent of angle F equals opposite 5 over adjacent 12. To get rid of tangent, you have to do the tangent inverse. So that would be with a little -1. So angle F is going to equal tangent inverse of 5 over 12. Make sure you're in degree mode and hit the second button when you put it in. So 5 divided by 12, that's going to get us angle F as approximately 22.62 degrees. All right, let's go ahead and take a look at this next one here. So we just have the picture here, and it says, can you verify that these two triangles right here are similar? And if so, explain why and give the similarity statement. So first of all, for part A, I'm going to write it here. Part A, we know that these are actually similar. Notice that we have a right angle there. So we have two 90-degree angles, and you happen to have vertical angles. So if you have two angles that are congruent between the two triangles, that makes these two triangles similar. So we can say that triangle EFG is similar to triangle IHG by angle similarity. And for part B, we're solving for D. So to solve for D, which is this length right here, we're going to go ahead and set up a proportion. So I'll start with D. Let me use the color here. So D is going to be over, and the side that it goes across with that is 80, equals this side, which is, I think that says 52, and that goes with the 60. All right, you can cross multiply. So you have 60 times D equals 80 times 52, and that gets you a total of 4160. Divide both sides by 60, and we get D as approximately, or we can make it equal to 69, and it's 0.33333, which is 1/3, and this is meters. Okay. All right, let's take a look at the values in this picture here. So we have to find A, B, and C. Well, let's start with A. I know two lengths of the side of a right triangle. I can use Pythagorean theorem. So to solve for A, we'll do 32 squared plus 24 squared equals A squared. And 32 squared is 1024. And 24 squared is 576. And then adding that to 1024 gets us 1600. Square root of both sides, that's going to give you 40 as your length C. So that's one, oh sorry, length A. Why did I change it to C at the end? These are all A. So technically it's the hypotenuse, but it is letter A. All right, so I know this is 40 right here. That's good to go. All right, let's go ahead and solve for B. Now notice I always look for this T right here. And if you have that T, you can set up that proportion. So this one is B over 32 equals 32 over 24. So B over 32, the middle, equals 32 over 24. It's almost like riding along, going up, back down, and across. All right, so we're going to go ahead and multiply this out. So cross multiply, we get 24b equals 32 squared, or 32 times 32, which is 224. Divide both sides by 24, and we get a total of 42, and we can write it as 0.6666, which is 2/3. And this is for B. And then for the last part is C, which since I have B and I have the 32, I can use a right triangle and Pythagorean theorem again. So I have B squared, which is the 42 2/3, plus 32 squared equals C squared. All right, let's go ahead and take this and square this. That's going to get us 1820 plus 32 squared, which is 1024. And so adding that together, we get, oops, let's go with calculator. There we go. All right, so 1820 plus 1024 gets us 2844. And then we're going to take the square root of that. Oh, square root of 2844 gets us about 53.3 as your C. All right. Let's go ahead and take a look at the next one here. So it has a man standing 50 feet from the base of a monument holding a camera 3 feet off the ground. So let's draw a picture of this. So I'll start off with the guy holding his camera. So he's holding the camera, click. That's height right here to here. is 3 feet. And he is 50 feet from the base of this monument. That's how far he is. He measures the angle of elevation, so from his eyes, he's measuring it to the top of the monument. And this is, I'll drop this thing in. This is 49 degrees from his camera. How tall is the monument? So, first of all, the monument will be from the length from the top all the way to this bottom here. So we know that once we solve for this height here, we'll just have to add the 3 feet that's over here on this side, on the end. Kind of think of it like this. Right? So this is going to be the 3 feet. And we'll have to find what this end is. So what we're going to do is we're going to use trig. Since it's 50 from here to here, this is also 50 feet here to here. And we're solving for this value right here, so I'm going to make that x. All right, so we have opposite, we have adjacent, that's going to be tangent. Tangent of 49 degrees equals opposite x over adjacent 50. Cross multiply, we'll get x equals 50 tangent of 49 degrees. So x will be approximately, let's see, 50 tangent of 49 is approximately 57.5. So this is going to be just the x part of it. And what we're going to do, actually let's do 5 to be consistent with the answer. So that's not the answer. This is 57.52 just from here to here. 3 feet is just from here to here. But what I really want to know is how tall the whole monument is from here to here. So we just have to add this together. So add 3 to this, which gets us 60.52 feet. Okay. Let's go over here. And this one is saying that we have similar figures again, and we're solving for m, and we're solving for n. So n and m. Here's m, and n is the full length from here to here. So we're going to have to solve for parts at a time. Now I notice that I have this length and this length, and this length and this length. So I'm going to go ahead and set up a proportion for that. So first of all, I have 6 over 12 equals 5.5 over m. Let's cross multiply. So 6 times m is 6n, and 12 times 5.5 gets you a total of 66. Divide by 6, and m is 11. So that's one of the sides. All right, now let's go ahead and solve for n on this side right here. Now I know that this full length is 8 right here, so I'm going to set a proportion again. I'm going to use 6 and 12 this time, 6 and 12. But this time, since I'm solving for m, I'm going to use n with the 8. All right, cross multiply, 12 times n is 12n. 6 times 8 is 48, divide by 12, and we get 4. All right, and then the last problem right here, we're solving for x. So we're looking at the proportion right here. Excuse me, hold on. All right, and then we have 12 over 3, because this is the triangle proportionality theorem. Since these are parallel, it splits the sides proportionally. 12 over 3 equals 2x minus 3 over x minus 5. Let's cross multiply. So we have 12 times x minus 5 equals 3 times this 2x minus 3. Distribute, we got 12x minus 60. Distribute, we get 6x minus 9. Move the x to the one side, so if I subtract 6, I get 6x. And add 60, that's going to get me 51. And then dividing both sides by 6, we get 51 divided by 6, which is 8.5. That's it.